presented this a while ago. Google's already fixed some things. I'll just leave that in the slides for anyone who's interested. But one of the more interesting things Google Gears allows, is it allows cache poisoning by design once you have an XSS bug somewhere. This is particularly interesting because a lot of different domains have trust relationships between each other by, for example, pointing script tags across domain. One of the ones I want to demo is a trust relationship between google.com and gmodules.com. Given gmodules.com is a domain that's completely designed to have user input on there and user script on there, it's meant to host completely untrusted data. It's pretty much irresponsible of Google to rely on it, but they have. And using the functionality provided to us by Google Gears, we can jump from the gmodules domain to the google.com domain. So how do I get out of this? Yes.
3 in? No.
No,
okay.
It doesn't matter. Okay, right. The one thing with Google Gears is the first time you use it from a given domain, Google asks you, are you sure you want to let this domain store some kind of data on your computer? This really isn't clear because it's in Italian. Hell, I can't read it, but I think that's the yes button. So anyway, so what this page does, it's on the gmodules.com domain. I'll just try again. Yeah, okay, good idea. Good damn MacBook. All right, so what this control does is it uses the local server object that Google Gears gives you, which effectively just allows you to capture our malicious payload from this particular URL that's on the same domain. And once it's done capturing it, we rename that file to this other file that a bunch of different pages on the internet include inside a script tag. So if we... If we go there, we see that essentially it's just some JavaScript which alerts whatever domain we're on. So, what? That's cancelled? No, that's cancelled. Okay, right. I totally got this. Right, so we go to a specific Google URL, which includes this script source and includes our script from that other domain, where we normally wouldn't actually be able to control that URL, but given Google Gears allows us to play with the cache, we can now say that we can now rename things there, and whenever people go to this page and have their cache poisoned, our XSS will execute. I found that originally here, but amusingly, since I left my own computer cache poisoned for a while, I found out that the OWASP website, the Open Web Application Security Project, which tells people what to do, has exactly the same issue. So where were we? Yeah, you use your MacBook. Yeah, I can use every key a second. All right. One thing that has been fixed now is that Google Gears had this functionality to create JavaScript files, to create JavaScript threads from specific files that you could load from a URL. And this could be done across domains. So if you could host some JavaScript on a particular domain, you could have it executed in the context of that particular domain. This has been more or less fixed as a way to conduct XSS because you also need to control the content type header. However, Firefox in 3.1, I'm pretty sure, are trying to implement web workers. Not sure if they're going to have that check or not. But interestingly now, due to this, hosting plain text is obviously dangerous because we can just put up our JavaScript. Hosting images was dangerous because we could create images that were valid GIF files and valid JavaScript, or valid JPEGs and valid JavaScript. But interestingly, hosting like XML that was properly escaped was also dangerous due to how Firefox has modified its JavaScript parser. Firefox has added support for this thing called E4X, I think it's ECMAScript 4 XML, which essentially gives you a new way of defining objects as and the way you define them is by XML. So yeah, as you can see up there, the line there creates an object with a bunch of different properties and variables and things. But the interesting part is it allows you to have embedded JavaScript constructors using these braces. So the value in here, once the JavaScript parser actually passes it, would be 3 instead of 1 plus 2. So what we could do, if we could inject somewhere that was valid XML, we could simply inject our braces into that XML, and yeah, and then point the Google Gears web workers at it, and then it would be executed in the context of the domain where we can inject braces. Particularly interesting because almost no one actually filters braces anywhere. It was especially interesting for sites that did AJAX and actually used the XML portion because they were obviously perfectly valid XML. This isn't so useful for this particular attack now since it's fixed, but in web workers. But this is interesting to us because this means that when we're doing some kind of cache poisoning and we want to abuse these kind of trust relationships, if we can't control the whole response, but we can inject braces into some valid XML, we can form valid JavaScript files and then do cache poisoning much easier. Of course, there are some caveats to this because the E4X parser requires fully valid XML and has a bunch of these restrictions which you can look at in the slides since we're running out of time. We also had a look at Firefox extensions because these are essentially pieces of trusted code that are written in JavaScript, XUL, and HTML. So cross-site scripting bugs in this kind of functionality result in code execution. The attack surface for these is kind of what you'd expect. If you get an input from the network, such as via the unrestricted XML HTTP requests, or if you get input from a web page, or things like this, then you're dealing with potentially untrusted entities. Common vulnerabilities are when you get some kind of JSON data from the network and then just put it into the eval function to get an object out of it. While this is also common practice in JavaScript apps, this is a much more serious issue here because being able to control the network doesn't mean you have code execution, but if they do something like eval JSON they get from the network, then you have a code execution bug that you can hit if you're on the local network. And similar kind of as injection because you have a lot of different sensitive objects that you might want to play with, like directory traversal, or like there are actual like SQL stores for extensions as well. So one of the things we want to look at is a specific bug that was similar to another Watchfire guy found about like, I don't know, 4 or 5 months ago, which started me with all this. It was rated as a low-risk vulnerability because there was, they couldn't figure out any way to exploit it. The easiest way when you're attacking some kind of extension to determine if you're actually running in a privileged context is to just have a look at the window object. If your current window object is a Chrome window, then you're running in Chrome, which is a privileged context. If it's just a window object, then it's running in a null context and you can't really do anything usually. So if we have a look at, close all these, can you close them?
Oh, yeah.
I'm sorry, I'm not a Mac user. How do I right click on this?
Instruments.
Yeah, that's right.
Fuck.
Where's it?
Instruments. Tamper data.
All right. So, oh no, cancel.
Fine.
Damn. Yeah. Okay. So the bug itself is pretty lame, hence the name of the file. What happens is if you have some kind of malicious file, and then you use the graphing functionality in Tamper Data to like graph them all, you'll result in an XSS bug. The one I'm using is just from the like HTTP headers where you have like 404 not found or 200 OK. You put like just some number, then your XSS, and it'll get executed. the reason I say this bug is lame is pretty much because it requires way too much user interaction to be useful. But when we go have a look at the window, we'll see that it's a fairly valid assumption to think that this bug is unexploitable, because when you have a look at the context, where is it selected, you get just a normal window object. So if you're doing just a typical analysis, yes, this is running as completely untrusted code and you can't do anything useful. Using the same type of things we talked about before, there are bugs in like Firefox which are usually typically low impact, but there are bugs in the access controls that allow us. Oh wait, we had to use this first. See, like I have to try to get owned here. So yeah, where is it?
Oh wait.
What just happened?
Here it is.
Right. So we were actually able to write an exploit which set this entry in the configuration of Firefox. Config.
Yeah.
Blah, blah, blah. Which said essentially the URL that Firefox gets updates from to whatever string we wanted. The default is this like SSL URL, and so Firefox updates are pretty much protected by the fact that you can't usually edit this config entry and it goes over SSL. So essentially when you go, right, how do I open that file? I need to open that PHP file.
Oh.
TD. Yeah. Okay, right. So yeah, no, you can't really see that. Okay, right. So the XSS bug is here right after, like in the HTTP headers. To exploit this, what we did, I pretty much used the same techniques that Stefano did to have a look at the access controls of the opener object in Firefox. So what I found was that in the opener object, all the browser default objects in there were properly protected, but any objects created by the extension had absolutely no access controls on them. So I could set any variables I wanted. So after fiddling around, I found out that you could also execute functions. And when you executed these functions, they executed in the privilege context. So we were able to edit all the variables in that context, so essentially control all the data those functions are working with and then call them. So we essentially say we want to edit the root preferences from nothing, then we want to set the particular config entry to whatever we want, and this essentially makes a bug that's typically considered completely unexploitable give us a path to code execution, since once we change where a user gets updates from, well, next time they open their browser, they're going to get their updates from us, right?
Okay, I think
wait. Do we have to stop yet, or no? We have. Where is it? No.
Because F5 is.
Yeah. Right. Okay. Yeah. Essentially, once you actually have typical code execution inside the privileged context, you can just like run executables, do whatever the hell you want. It's pretty easy from that stage. As a side note, given that JavaScript can be privileged, if you can overflow into the context markers and change them, then that would be potentially one way to defeat dep and other things which stop x86 execution. And since we've run out of time, we'll probably just stop that there and let you have a look at them if you...
Yeah.
Oh, wait. I say we take a look at this.
Okay,
That's also...
just 2 words about the Opera exploitation, which was researched a couple of months ago. It's about the Opera 6.0, 9.6.0, And what was the problem is the problem was that it was taught as